Hello, my name is Daniel Nenny, and I'm the founder of SemiWiki.com, the open forum for semiconductor professionals. Since going online in 2011, SemiWiki.com has experienced more than 4 million users. If you're not a member of the SemiWiki community, please register as my guest. I hope to see you there. Today's webinar is titled, Accelerating Semiconductor Design with Hybrid Cloud. Today's chips and electronic systems are more complex than ever before. Additionally, market competition is at an all-time high, driving the need for designers, CAD teams, and foundries to innovate, reduce costs, and accelerate schedules. Hybrid cloud computing is positioned to deliver a competitive edge, ultimately driving a new era in the semiconductor industry. Join this webinar to learn about the benefits of a hybrid cloud approach to empower your team to accelerate time to market and reduce risk. See Rescale's all-new hybrid cloud platform built to seamlessly transition workloads to the cloud for increased scale and performance while maintaining the highest level of security and efficiency. Please submit questions or comments in the questions box, and we will respond via email after the webinar.
Thanks, Dan, and welcome to Accelerating Semiconductor Design with Hybrid Cloud webinar by Rescale. My name is Jose Fernandez, responsible for semiconductor and EDA partnerships at Rescale. And with me are my partners, Jeff Critton, Enterprise Account Executive, and Riaz Liaquat, Solutions Architect and expert in EDA applications. Let's begin with a quick overview of Rescale. Rescale is the leader in HPC cloud with over 600 applications already available in our platform, able to run on over 100 data centers worldwide, and with over 200 enterprise customers. Rescale has extensive partnerships in the EDA ecosystem with CSPs such as Amazon, Microsoft, Google, and Oracle. Our partners in the foundry ecosystem, such as Samsung Safe, TSMC, and UMC, and leading EDA vendors such as Synopsys, Cadence, Mentor, Keysight, and Ansys. We're here today because of the increase in chip design complexity that is driving explosive growth in computing needs. To address these computing needs, we need specialized architectures to drive the right performance, hybrid and cloud execution, full stack performance intelligence, and also control over the architectures, finances, and security in order to be successful on the cloud. Rescale brings full stack management and optimization that allows the bridging of the gap between EDA vendors and the cloud service providers. Rescale provides application lifecycle and licensing management, workflow automation, and the ability to submit jobs into multiple cloud providers with optimized performance and enterprise class security. We bring all this complexity and encapsulate it in a easy to use platform, and yet very powerful, that you see here in the middle, that allows you to run applications from key providers such as Keysight, Cadence, Mentor, Ansys, and more on one or multiple of the cloud providers shown at the bottom, while also collaborating with your partners in the foundry ecosystem. In summary, Rescale provides one platform that allows any application to run on any infrastructure with an intelligent control plane that allows you to optimize hardware and software performance, user, team, and workflow productivity, plan and manage your costs, and provide security compliance that meets the highest standards available in the industry. I will now pass it over to Jeff to take us over how these value propositions apply to semiconductor development.
Thanks, Jose. So when you think about the platform, let's take a look at the key elements that make this easier to use and powerful. So number one, is that we provide a turnkey platform. And what does that mean for a user? That means when you log on to Rescale's platform, you're going to see the EDA applications pre-installed and ready to use. All you need to do is upload your data and essentially rerun the scripts you would have run on premise. So it's sort of like an instant on EDA design cloud. That cloud gives you the agility you need. If you recall Jose mentioning a 10x complexity increase in compute requirements for new designs, you'll be able to scale as high as you need to scale to get the runs down to less than a day, which are probably taking you for longer than a week today. Of course, with the cloud, you have access to nearly an infinite number of machines, but your finance guys will need to be able to control that and budget for that. And so we have all the controls you need to make sure that specific projects are getting access to the compute they need to be successful. Finally, everybody talks about security. You can be assured that Rescale offers the best-in-class security available in any cloud platform. With respect to workflows on the platform, we've targeted a number of workflows. What we see today with advanced node, things like static timing analysis at sign-off and IR analysis require thousands and thousands of cores to be able to do these runs in less than one day. We've done a lot of work to optimize the runs with respect to specific core types that you see listed on this slide. So as a user, when you log into the platform, we'll give you some guidance for the right type of compute for the workload you're looking to run. Most of our customers today have an on-premise data center that they also need to use and leverage given the investments that were made there. So the concept of a hybrid cloud is important to all of our customers. And what that enables you to do, it enables you to direct your workloads either to the cloud or onto your on-premise data center. We even offer some automation here via our intelligent control plane, such that with some metrics, you can automate that process so the jobs will automatically run on-prem or in the cloud, and thus make sure your on-prem data center is fully utilized and your cloud costs are somewhat minimized as well. All designs will need some foundry PDK information. And so what we do with the PDK is we store this in our high performance storage area. As you think about this, many of your users will be accessing this data at the same time. So it'll need to be NFS compliant. And given our high performance storage solutions, that will work seamlessly with all your EDA applications. With respect to partnerships in the ecosystem, we're quite excited about our most recent one with Samsung. Samsung's Advanced Foundry ecosystem has been cloud enabled. So that's what Safe CDP stands for. And Rescale is the platform that powers the Samsung Safe CDP. So for all the Samsung Foundry customers out there, if they're looking toward cloud, all they need to do is contact us and we have a full solution set ready to go based on Samsung's process data. Some of the results from using cloud to accelerate design throughput. If you look at place and route, here's a couple of examples. By going from a sort of low performing 8-core machine to a higher performing 24-core machine, Gaon Chips was able to shave 30% off the overall runtime, getting it down to less than 100 hours. With additional cores, they could bring that down further. But that was a significant 42-hour runtime reduction, which gave them more turns per session than they would have normally had. Silicon Catalyst is also one of our key partners. Silicon Catalyst is a funding organization for a number of startups around the world. They help them get off the ground and become successful. Rescale is an in-kind partner to Silicon Catalyst. So many of the Silicon Catalyst portfolio companies, some examples are Aerodin, Quadric, Multifractal, are using Rescale as a platform to get their designs up and running in the cloud immediately, as opposed to having to spend CapEx dollars on IT infrastructure. And they've been very successful in doing that. I mentioned Samsung earlier. One of Samsung's customers is Gaon Chips. And here's a short video just of Gaon Chips talking about the power of using the cloud to reduce their design throughput time.
Safe CDP by Samsung Foundry and Rescale is an exciting new paradigm for the semiconductor industry.
Safe CDP is a key strategy in making Gaon chips highly competitive. Gaon in Korean means the center of the world. Established in 2012, Gaon Chips continuously works to be technologically competitive in the fab industry. Gaon Chips strives to implement the best technology and test new design paradigms to satisfy customers, especially in semiconductor chip design for both front-end and back-end.
By collaborating with Rescale, a leading company in high-performance computing, we wanted to find a way to give fabless customers direct access to all the benefits of working in the cloud.
Some might wonder how much hardware is needed to create a small chip. The process of designing and verifying semiconductor chips is extremely complicated. Semiconductor chips require many different EDA tools with unique computer specifications based on their types, and obtaining new hardware each time is realistically impossible. Using a computer without optimal specifications takes a very long time, and projects usually have tight deadlines and require a great amount of engineering resources to complete them on time. Our engineers' time is a great company asset, so if we can save their time and give them more time for research, we can make the company more competitive in the market.
One of the advantages of using Safe CDP is being able to save time. An engineer knows which computing hardware is best suited for a given project. By using optimized hardware and reducing design and verification times, we have more time to focus on research, which undoubtedly leads to a better outcome.
From the engineer's perspective, we can focus solely on the design process. By simply logging in, we access a convenient environment for designing. Previously, we commonly found that there was no way to predict the result's final data size, which created stress for the engineers. Since we can now easily secure a scalable storage space needed for any size results, we don't have to worry anymore and can focus on the design process.
Another advantage of how Safe CDP improves competitiveness is its ability to provide a collaborative environment. The process of obtaining and managing foundry design kits and process scripts is complex. Using Safe CDP, foundry design kits can easily be obtained and instantly applied to the design process.
Communication between engineers is also easy. Normally, with many engineers working on a single project, file handover in each process is inconvenient. Safe CDP allows engineers to be able to communicate and share results, despite being physically located in a different region or abroad.
The bottom line is, customers are able to simply select the best tools and hardware needed to accomplish their goals.
Gaon Chips supports its customers by continuously growing and innovating. We are pleased to have Safe CDP as the driving force behind achieving our goals.
Great. I hope you all enjoyed the Gaon Chips video. And with that, I'm going to hand it over to Riaz, who's going to take you through a Mentor Caliber demo on the platform.
Thanks, Jeff, for the great introduction. Over the next 20 minutes or so, I want to walk you through on how you can run Caliber DRC workload and Rescale. But before we get into the actual demo, so I want to talk about a couple of things from a technology perspective, how a Rescale platform is well suited to run EDA workloads. So if you look at the platform today, there are like several ways our customers can connect to our platform. So they could connect via web UI. We have seen that in the EDA space, customers tend to use the APIs or more around CLI. So we do support those functionalities as well. From an EDA stack perspective, we have the applications from different vendors such as Cadence, Mentor, Ansys, Keysight, all pre-configured. We have close to 50 plus applications, and this number only keeps growing as we continue to work with customers. We spend a lot of time on the infrastructure automation to make sure that your jobs can successfully launch and run to completion, irrespective of wherever the capacity is. So we have done a lot of intelligent automation on the infrastructure side. We also have like robust solutions for license management. So this could mean that you could have your license servers located on-prem, which we can connect via VPN, or we can also host the licenses on the Rescale as well. The networking security are also like other important aspects of our platform. And we do have like, detailed security measures in place. And you can also set up like additional security policies such as multi-factor authentication. In terms of the job architecture itself for EDA, I want to say that at a high level, there are two main use cases. One is a lot of customers tend to run EDA workloads in batch. And the second is customers also run it in an interactive fashion, either because the workload demands it, or like they might also want to do some post-processing of the data. So we do have solutions to address both the different use cases. We have like compute nodes from different cloud service providers such as AWS, Azure, Oracle, and Google Cloud. Some of these nodes also contain like high memory or high bandwidth. Depending on your type of workloads, we can definitely have different compute nodes to support it. And we also have like very robust VDI solutions, which lets you monitor your live running jobs as well. In terms of the storage, we do support both like a persistent NFS mount shared storage as well as object storage. So let's talk about the demo example today. Today we'll be walking through on how you can run DRC, or what we call as design rule checking verification workload on the Rescale platform. The way our customers run this workload today is in three parts. The first is customers set up this device called as high performance storage. So this is essentially like a persistent NFS mount shared storage. You can bring in your input files, your process design kits, your libraries, and host it there. The second part and the most compute intensive part is where you can run Caliber DRC. One of the nice things about this application is you can run it in batch. And we've heard from customers that some of their DRC run can take up to like 2 weeks. That's one of the amazing benefits of using cloud, where you can cut down your compute time from 2 hours to even like a couple of hours. So we are talking like, great levels of productivity and accelerating innovation here. And once you run the Caliber DRC in batch, customers can also open via an interactive session and do a live processing of the data as well. So this helps to run the whole DRC workload in a very comprehensive manner. And with this, I want to jump into our platform and walk you through how to actually set it up. So let's log into the platform. There are multiple ways, as I mentioned, you can connect to our platform. The most common use case and what 80% of our customers use is through a web-based UI. So here I've logged into to the Rescale platform. And my primary goal here is to demonstrate how you can run Caliber DRC workload in batch. The first thing is I have a storage device which is set up and which is ready to go. So this storage device is essentially a persistent NFS mount shared storage. So I can decide on what's the type of size of the storage that I want. The beauty here is you can also extend the size of the storage. And if you want, you can also spin up like big storage devices as well. So if you actually look at where my input files are located, so in this case, I'm planning to run a couple of test cases. And so if I actually go into one of the test cases, so I've uploaded a set of input files, which is required to run a Caliber DRC job. I have my rules file. I also have my OSS or the chip design file, and I have the layer information file. Right? So all these are like configured, and this is all hosted in my storage device. Now let's walk you through on how to actually use these input files and run Caliber DRC. In order to do that, so we can click on this new job tab here, and I'm going to give this job a name. The framework is very simple here. So you need your set of input files, which can be, if it is part of your personal cloud storage, you can upload it from there. You can also upload it from your local machine as well. For most of the EDA use cases, we've seen like customers would pretty much bring those input files and park it in a storage device, and then mount the data of the storage device, which is what we are going to do here. So we are going to select the storage device, and then we are going to mount to our live running device here. For this example, I'm interested in running the use case B. So I'm going to select all the 3 files which is required to run the job. So I select all the 3 and hit attach. By doing this, I'm mounting these input files to the compute cluster. So I have my input files ready to go. The next step is choosing the application. This is where really Rescale shines. We work closely with our ISV partners such as Cadence and Mentor to onboard those applications, test and make sure that those applications are running in a cost performant manner. So in this demo, we are going to be using Caliber DRC. So let's go ahead and select that. Once you choose the application, you can also choose a version of interest here. This is one of the big advantages, especially in the EDA world, where users tend to stick to a particular version because of the requirements of the project. So here, like when we onboard a version on the platform, we don't deprecate it. So I can select the version of interest here. So pick the 2019 version. And you can see that the command line is automatically populated. All we need to do is to add the name of the rules file. So in order to do that, let's just go here and copy this guy. And then the hyper flag is something that is required to run Caliber DRC multi-threaded or across multiple nodes. So you can select that. In terms of the licensing, in the EDA world, it's bring your own license. So if you have a license which is located on-prem or which is located on Rescale, which is what we are doing in this case, we can use it for running our job. So I have a Mentor license, which is running on this license server. And if I click on check availability, it also shows me like, what are the features that is currently available for my organization and how many can I actually check out. So this is really helpful if you are planning to run a number of jobs. So we have our input file, we have our application. The next part is choosing the hardware. So on the Rescale platform, we have close to 60 plus different hardware configurations from public cloud service providers such as AWS, Azure, Oracle, and Google Cloud. The beauty of using a platform, something like Rescale, is you can pick and choose whatever hardware makes sense for your application. So you can really like right size the nodes, and this helps you to run the workload in a cost performant manner. In this case, if I want to be running like a high memory application, for example, so I can click on the high memory section, and that gives me a list of many different options here. So you can also choose like how many memory per core, what is the type of interconnect, and so on. So as a user, you really have a lot of flexibility to choose the hardware. And then, so in this example, let's say that this is a fairly small model that I'm going to be running. So I'm going to be picking the general purpose hardware, and I'm going to be using a code type called as Emerald. So once I pick the code type, you can see that we also provide information around like what is the underlying architecture, whether it's an Intel machine or an AMD machine, or we have also been working closely with AWS to onboard the ARM code types as well. So you get those information, and depending on the type of cluster that you want to run, you also get your cluster configuration. How many cores per node, what is the memory of the cluster that you're trying to build, and so on. Right? So once we pop in all this information, then we can go to the next step. Post-processing is purely optional. So if you don't have any like Python or post-processing script, you can skip this part. And we are pretty much ready to launch this job, right? So at this point, so we have our input files, we have our software, and we also have our hardware. And now we are ready to run this job. So once you launch a job, what happens is we do an validating input. Essentially, we are making sure that you have the right input file, you have access to a license, and you also have, more importantly, budget to run the job. Once those things pass, what we do is that we then stand up a cluster based on your requirements. In this case, we'd be standing up an 18-core Emerald cluster. And once this cluster is up, we'll be running Caliber DRC in batch. And once the application is completed, it's automatically, the cluster would be terminated, and your data would be moved back to your personal file storage. So you can see that from this point, like the user doesn't really have to do anything. So there is no user intervention required. All the abstraction is done by the platform, and it's all automated. Now, there are a couple of things that customers would be very interested in doing when the job is running. Let's say I launch a job, and I'd like to understand like what is the status of my job. Right? what step of the simulation it is in currently. So what I could do is, so we have this feature functionality called as live tailing. So where I can go take a peek at the log file to understand like what's going on with respect to the simulation. We also have like additional ways to monitor the job as well. So you can SSH into the compute node. Like for example, I could SSH in and do like a top command to understand like what are the different processes that are running. And you can also SSH from your local machine as well. So you have a lot of flexibility. Now, along this way, let's say that I'm running this job and I run into some issues. You can definitely reach out to our support team, and it's very easy to do that. So you can click on the share button and you can say that I want to share this job with support, and you can enter in your message here. So from this, like what I wanted to show is that it's very easy to launch any type of EDA workloads, not just the Calibre DRC on the Rescale platform. And the way and it's very easy to do it through the batch workflow. Now, there are certain cases where users would want to run a workload in an interactive fashion, or take the results which is coming out of a batch run and do a post-processing on top of it, right? In this scenario, this particular Calibre DRC analysis is going to generate an ASCII file, which you can then load it into another mentor tool called as Design Drive and do like an interactive analysis. The framework to set up an interactive job is very similar, and I want to quickly demonstrate here. So you can say that you set up the workflow in the same way. You have your input file, and you can choose the mentor interactive tile in this case. And once this cluster is up and running, what happens is you get this option called as connect to an interactive session. So you can click to that interactive session. When you connect to an interactive session, from this point, your environment becomes very similar to how you have it on-prem. So you can load the application, and then once you're inside your application, you can do like further analysis, which is kind of what I'm doing here. So I have my design drive running with my application, and I'm also have the RV loaded with my ASCII database. And now what I could do is like, one, just by looking at this, I can see that most of my layers are passing DRC check. There are a couple of errors or polygons which are off axis. And I can take an action either to ignore this, or like I can also take an action to modify it, right? So for this, like what I could do is I can click on this, and I can zoom to this location to understand like, what is a polygon and what I need to fix here. So just to recap what we have learned so far from the demo. So we saw that how you can bring your input files and set up your environment in a storage device. We saw that how you can run Calibre DRC in batch, and how you can actually take the data and do an interactive analysis. I hope this demonstration was helpful. With that, I want to pass the ball to Jose.
Thank you, Riaz. In conclusion, Rescale is easy and powerful EDA on the cloud. It provides turnkey capabilities to run your EDA applications on the best hardware from leading cloud providers, agility to shorten your time to market. It is a controlled and secure environment. Please let us know if you have any questions. On behalf of myself, Jeff, and Riaz, I thank you for joining us. And Dan, back to you, and thanks for having us.
That concludes our webinar. Thank you all for participating in the SemiWiki webinar series, and have a good day.